Okay, this is chapter 3 homework for Physics 101. It says a person walks 25 degrees north of east for 3.1 kilometers. How far would that person walk due north and due east to arrive at the same location? So I have this person. If I draw out my coordinate system, this is north, south, east, west. They walk 25 degrees north of east for 3.1 kilometers. So something like this. This is 25 degrees. And it's 3.10 kilometers. Now I want to figure out how far a person would walk due north and then due south, or due east rather, to arrive at the same location. I prefer to draw my vectors like this. So we're first going to answer the question due east and then due north. But those are the same because it's the same triangle. So I want to find the x component and the y component of that vector. For the x component, is going to be the magnitude, 3.10 kilometers, times the cosine of 25 degrees, and that's equal to 2.8 kilometers. 2.80, excuse me. No, just 2.8 kilometers east. And then for the y component of the displacement is 3.1 kilometers times the cosine of 25 degrees, and that is equal to 1.3 kilometers to the north. Now notice that I got these from the definitions for sine and cosine. So if I draw my triangle like this, this is my angle theta, this is x, this is y. The cosine, and this is my hypotenuse, I'll just call it h. The cosine of the angle theta is x over the hypotenuse, so the x component is equal to the hypotenuse times the cosine of the angle theta. And I should have a mistake here, sorry, this should be sine of the angle theta. Now the sine of theta Okay, this is Physics 101, Chapter 3 homework. It says a person walks 25 degrees north of east for 3.10 kilometers. How far would the person walk due north and due east to arrive at the same location? So if I draw my coordinate, this is north, south, east, and west. My person is walking 3.10 kilometers at an angle of 25 degrees north of east. So I want to know what is the x component and the y component of this vector. The x component is how far he walks east, and then the y component is how far he walks north. So first I'm going to start with the x component of the vector. Now if I have this triangle, it's like this. This is x, this is y, this is h, this is my angle theta. The cosine of the angle theta is so cos a over h, so that's x over the hypotenuse. So if I want to find that x component, it's going to equal the hypotenuse, which is 3.10 kilometers, times the cosine of the angle, which is 25 degrees, and we find that that's equal to 2.8 kilometers, and it's to the east because it's positive. If it were negative, it would be to the west. The y component is equal, here I have the sine of the angle theta is equal to opposite over hypotenuse, so that's y over h. So y then is equal to the hypotenuse, which is 3.10 times the sine of the angle theta. So that is 1.3 kilometers to the north. So the person will get to the same destination if he walks 3.1 kilometers at 25 degrees north of east, or if he takes these two legs, 2.8 kilometers east and 1.3 kilometers north. While exploring a cave, a spelunker starts at the entrance and moves the following distances: 75 meters north, 250 east, 125 at that angle, and 150 south. Find the magnitude and the direction. I always like to first draw the vectors. So I have 75 north, 250 east, 125 at 30 degrees is 125, and this angle is 30 degrees, and 150 meters south. It's just going to go down a little bit further than that. 150 meters south. Now I want to find what is the magnitude. I want to add up the x and y components of each individual vector, and the sum of those x and y components will be the x and y component of the resultant vector. That is the sum of those 1, 2, 3, 4 vectors. So I have to make a little table. X, y. The first vector, 75, has no x component. The y component is positive 75 meters because it's up. The next one, 250, has an x component of positive 250 and no y component. The next one, the x component is 125 cosine of 30 degrees, and the y component is 125 sine of 30 degrees. And then finally the last one, it has no x component, and the y component is minus 150. Now, I add up these numbers, and I find that they're equal to this, 358 and minus 12.5. So, if I start here, and I wind up there, that's my resultant vector. It's the sum of those 4 vectors. I can take that distance, or I can take these two legs. I can go 358 meters to the east. This is 358. And then I go minus 12.5 meters to the south, or 12.5 meters to the south. So now I have this triangle, 358, 12.5 are the legs. I want to know the length of the hypotenuse, and I want to know this angle. I'll call it phi. So first, to find the magnitude, I'll just call it d. D is equal to the square root of 358 squared plus 12.5 squared. The 358 dominates, so it's 358 meters, but I really don't want to keep 2 sig figs, so I'll just list it as 360 meters. Now, to find that angle, phi, it's the inverse tangent of opposite over adjacent, so TOA, T-O-A. The tangent of the angle theta is the opposite over the adjacent, so the angle theta is the inverse tangent of opposite over adjacent. The opposite is 12.5 over 358. If I do that, my calculator should be in degree mode. Comes out as 2 degrees. Alright, that's 2 degrees below the x-axis, below the positive x-axis, but in fact here we're talking in cardinal directions, so it's actually 2 degrees south of east. So that's the answer for the angle, that's the answer for the magnitude. Which of these examples of vector addition are correct, and which are incorrect? Okay, well, I want to add up the vectors a plus b. This is not the correct way, because I should have a and then b, and then a plus b is that vector. So that's not right. In a similar way, here a and b are meeting at this point. That's not right. This is the correct way to add vectors. A to b, and then we draw from the tail to the tip, the tail to tip method. Alright, so A is the only correct. Alright, the third one is the only correct, the other 2 are incorrect. This figure shows 2 vectors A and B. Graphically calculate the following. So first I want to do A plus B. I'm going to draw these vectors a little smaller than they're drawn, so let's see, I'll draw, oh no, I'll just do it the way it is. So here I have A, that's A, and then I draw B, looks like that. So graphically, not exactly to scale, but pretty darn close. That's A plus B. Then if I want to do A minus B, I'll draw A, and this is minus B. It's just opposite direction. And then A minus B looks like that. Now negative 2B I want to double b and then make it go the opposite direction. So negative 2b looks something like this. I double the length of this vector and I make it go the opposite direction. And then a minus 2b. Here's a, negative 2b, which is twice the length of b. And so this is the vector a minus 2b. If you walk 35 kilometers at angle 25 degrees counterclockwise from east, and then 22 kilometers at 230 degrees counterclockwise from east, find the distance and direction from your starting point to your destination. Alright, this is a little more complicated than the previous one just because of the way the directions are given. So it's easier just to draw the vectors from the origin and then add up the x and y components. It doesn't really look as pretty, but it's a lot easier to do it this way. So let me just draw these two vectors with their tail at the origin. The first one is 35 kilometers at 25 degrees counterclockwise from the east. Counterclockwise from the east. So this is east, north, south, or excuse me, west, south. So this is my first vector. It's 35 kilometers and it's 25 degrees counterclockwise from the east. And then my second vector is 22 kilometers, 230 degrees counterclockwise from the east. That is going to be right here. It's 22. And it's 230 degrees from this axis. And so from here to here is 180 degrees. So an additional 50 degrees from the negative x-axis. So I'm going to label that angle as 50 degrees. I'm sorry, this should be 35 kilometers, and this should be 22 kilometers. Now, I just want to add up these vectors the way that I did before, and the resultant and magnitude will be the sum of the two vectors. So I'm going to draw my table with my x and y vectors. I have 35 cosine of 25, and then I have negative 35 sine of 25. It's negative because that y component of the vector points down in this otherly direction. And then I have negative 22 cosine of 50 because it's in the west direction, or the negative x direction, and then 22 sine of 50. If I add up these values, I get 17.6 kilometers and 2.06 kilometers. So those are the x and y components of my resultant vector. To find the magnitude, which I'll just call d, it's the square root of 17.6 squared plus 2.06 squared, and that's equal to 17.7. I'm going to round it off to 18 kilometers because I had two sig figs up here. So 18 kilometers is my magnitude, and then I also need to find my direction. Just as I did before, it's the inverse tan of the y over the x. That's 2.06 over 17.6, and that gives me 6.7 degrees. And this is where you want to think about these vectors, and you might even want to redraw them. So I'm going to redraw them here. My first vector was down like this, and then my second vector was sort of like this. So my resultant vector is going to be in this direction. So this angle is 6.7 degrees, and so the direction then is 6.7 degrees above the positive x-axis. If you were dealing with just coordinates, xy coordinates, or, as is correct for this problem, 6.7 degrees north of east. Or clockwise from east would also be appropriate. And actually, I just realized that there's a problem here. This is counterclockwise from east, and the problem should actually read, instead of reading counterclockwise, it should read clockwise, like that. A brick is thrown upward from the top of a building at an angle of 25 degrees to the horizontal. and with an initial speed of 15 meters per second. If the brick is in flight for 12 seconds, what is the horizontal displacement of the brick? How high is the building? What is the maximum height of the brick in its trajectory? This projectile motion problem, I find it always helpful to draw a picture. There's the building. I have this object, I'm throwing it off the building. It's at an angle of 25 degrees with an initial speed v naught is equal to 15 meters per second. The brick is in flight for 12 seconds. It follows a trajectory that looks something like this. My angle theta is 25 degrees. My acceleration in the y direction is minus 9.8 meters per second squared. The acceleration in the x direction is 0 meters per second squared. I want to know what is x equal to, and I also want to know what is this height. I'll call it y. What is y equal to? Alright. In addition, I want to know what is this y. I'll call it y max. I want to know x, y, and y max. First thing, and the easiest thing to find, is x. X is equal to v naught xt plus 1/2 axt squared. That's one of your basic kinematics equations. However, the acceleration in the x direction is 0 because there are no forces acting on it in that direction, and so it's just v naught x times t, but that's equal to v naught cosine theta times t. So that is 15 times the cosine of 25 times our time, which is 12 seconds. Problems are usually a little easier if you already have the time. This works out to be 160 meters. That's our x range. The next thing I want to find is y. That is, what is this distance? I know how long it's in the air, so I can just say that y is equal to y naught plus v naught t plus 1/2 ay t squared. I know all of these values. I know v naught y, I know t, I know ay, and I know y naught. You'll usually just set y naught whatever you want it to be. I'm going to say that this point is y naught equals 0. So my beginning point is y naught equals 0, and so that's y naught. I set it equal to 0, and then I just solve for y. V naught y is 15 times the sine of 25. That's the y component of my initial velocity. The time is 12 seconds. The acceleration is negative 9.8. And the time is 12 seconds. If I put those numbers in, I get negative 630 meters. And you think, why is it negative? Because this is 0. Then this point down here is negative 630 meters. So I can just report the height of the building as 630 meters. Just leave the negative off. Okay? But it's important that you get the negative, because if you leave off that acceleration as being negative, then you're going to get a height for the building that's much too high. Okay, now that's the second part that we want. This was the first part. Now for part C, what is the maximum height of the brick in its trajectory? This is a little trickier. I know that the velocity at the top is equal to 0. I need to know what is the time at the top. So I want to find out what is that time at the top. So I say v at the top is equal to v naught plus a times t at the top. This is the y direction, because the velocity in the y direction goes to 0 at the top. And then I put in my numbers here. 0 is equal to 15 times the sine of 25 degrees plus minus 9.8 times t at the top. If I solve this for t at the top, that is, what is the time when the projectile is at the top of its trajectory, I get 0.65 seconds. So it occurs pretty quickly. Most of the time it's going down, because it's dropping 630 meters. Alright, but it takes a little more than half a second to get to the top of its trajectory. Then I want to figure out what is the height at the top. So I just say y is equal to y naught plus v naught yt plus 1/2 ayt squared. I'm going to set y naught equal to 0 at this point again. That means that at this point my y naught is 0. More about that in just a second. 0 plus 15 sine of 25 plus 1/2 minus 9.8 times 0.65 seconds squared. Actually, I left out a 0.65 here, so you need to put that in there as well. Alright, because it's v naught times t. If I put in those numbers, I find a y value of 2.05 meters. Alright, or 2.1 meters. That means that the distance from here to the top of the building is 2.1 meters. So the actual y max is equal to 630, which is the height of the building, plus 2.1, which I'll just list as 632 meters. Please find a car with a distance w equals 20 meters from the base of a cliff of height of h equal 100 meters. How fast was the car going when it went over the edge? Solve the problem symbolically first, and then plug in the numbers. Alright, so we have this car. It goes off of a cliff. Let's say it's a police car. Alright, it goes off of a cliff. The cliff has a height of 100 meters. And the car follows a trajectory. It's like that. And it goes a distance w, which it says is equal to 20 meters. Alright, just to be standard, I'm going to relabel these as x and y. That our y is 100 meters, our x is 20 meters. So, I have two equations, two kinematics equations. Y is equal to v naught y times t plus 1/2 ayt squared. That describes the y motion. And then x is equal to v naught x times t. Now v naught y, since it's going at an angle of 0, is equal to 0. There is no initial velocity in the y direction. Alright? And v naught x is just the same as v naught, because all of the initial velocity is in the x direction. Now, both of these have two unknowns. Actually, no, never mind. No, they don't. So I want to solve this first equation. Y is equal to 1/2 ayt squared. I'm going to solve it for t. So t is equal to the square root of 2y over a. Now I can plug this in. And then likewise, I can go over here and I can say that v naught is equal to x over t. I want to know what v naught is, so I can just plug this in for t, and then I have an expression for v naught. So v naught is equal to x over the square root of 2y over a, which is equal to x times the square root of a over 2y, and then I just put in my numbers. So that's equal to x, which is 20 meters, times the square root of a, which is minus 9.8 meters per second squared, over 2y, which is 2 times 100 meters, and that gives me 4.4 meters per second. Left a negative sign off here. You need that because it cancels out the negative in the numerator. The reason it's negative is because we called this y naught equal to 0. So down at the bottom, our y final is actually negative 100 meters because we're going down. So the answer is 4.4 meters per second, and this is the expression for v naught. You throw a ball with an initial speed of 10 meters per second at an angle of 30 degrees. It lands some distance away. what is the maximum height and the range of the ball. This one's similar to the other questions, projectile motion, but it's a little different too. I throw a ball, I throw it at an angle of 30 degrees. It follows a trajectory like that. I want to know what is the range, x, and I want to know what is the maximum height, y. Alright, my first job in this is to find the time. Whenever you don't have the time, you want to consider, how do I find the time? And in order to find the time, you have to analyze the y motion. Alright, we know that the velocity in the y direction is equal to 0 at the top. Further, we know that the time required to reach the top is 1/2 of the total time. So if we can find the time at the top, then we have the total time, because it's just twice that. So, I say v final in the y direction is equal to v naught in the y plus ayt, and I'm going to look for the top of the trajectory. So vf is equal to 0, v naught is 10 times the sine of 30 plus minus 9.8 times the time at the top. And so I solve for the time at the top, and I find that it's equal to 0.5 seconds. So the total time is twice that, so that's equal to 1 second. So I'm almost there. Now I want to know the x range. It's just equal to the velocity in the x direction times t, because the acceleration in the x direction, let me just write this, the acceleration in the x direction is equal to 0. Alright, so this is 10 times the cosine of 30 times t, which is 1 second. And that's equal to 8.6 meters. Alright, now I want to know the height. Y equal to y naught, v naught yt is 1/2 ay t squared. And now I want to consider what time that I use here. Do I use the 0.5 seconds or do I use the 1 second? I want to use the 0.5 seconds because that's how long it takes to get to the top of the trajectory. And if I put in the 0.5 seconds, it'll tell me what is the y position at the top of the trajectory. Y naught is 0, so I'll just leave it out. It's 10 meters per second. Sine of 30 is 0.5 seconds plus 1/2 minus 9.8 times 0.5 seconds squared. If I put this in, get 2.5 plus a negative 1.2. 2.5 minus 1.2 is 1.3 meters. That's the answer.